Welcome, dear students. So, this is problem of friction. So, the problem is knowing that the coefficient of static friction between the collar, so this is the collar C, and the rod is 0.35. Determine the range of values of P. So, this is the applied force P. So, we have to find out the range of values of P for which equilibrium is maintained when this angle theta is equal to 50 degree and m, this applied couple, is 20 Newton per meter. So now let us solve this problem. So solution, I am writing solution. So first I will draw the free body diagram of this rod AB. So this is the rod AB. So in this rod we will be having reactions here. So you can call it AX, AY, and then we have a force here. Sorry, yes. So this force we will have, and the direction of this force is this. Okay, so let us call it FBC. Okay, so what we can do for equilibrium, we can take the moment about A and it should be equal to 0. So then we have M, and we can break this force FBC into two components. One component will be here and one component will be here. So the moment, because of this vertical component, will be 0, so we will have only this, and this moment is opposite to this, so we can write it minus FBC cos theta is equal to 0. Okay, so now this is 20 FBC and this is 50 degree equal to 0, and this will give us FBC. So the value of FBC comes out to be 311.45 Newton. Okay. Now second thing we will we will make the free body diagram of collar C. Now there are two conditions. One condition can be motion impending upward and motion impending downward. So let us consider first case, motion impending downward. Okay, so we have this force P, that if motion is impending downward, then friction force will act here, and this friction force will be mu s into N, and we will be having N normal, and then we have this force FVC, and this angle is 50 degree. 50. So now we have all the forces that are acting on the collar. So we can have for equilibrium summation of Fx is equal to 0. That means FBC cos 50 degree minus N will be equal to 0. So from this we can get n. So the value of n comes out to be 200 Newton. Then we have summation of Fy is equal to 0. So in the y direction we have P acting downward, then FBC sine 50 degree. So the component of this force, okay, and minus frictional force. This is the frictional force F. So we can directly write it. So just a minute. So mu s is given as 0.35. So mu s into n, which is we already get 200 equal to 0. So from this we know the value of this FBC. So we can get the value of P, which comes out to be 168.35 Newton. Now second scenario can be when this collar is impending upward, okay. So FBD of collar C, motion impending upward. So again the diagram will remain same. So here we will have FBC is 50 degree, FBC, then we have P, and friction force will again act downward. So this is the friction force, again mu s n, and here we will have n, okay. So again summation of fx is equal to 0, summation of fy is equal to 0. So this equation will remain same. Now in the y we have p uh, minus fbc sine 50 degree, and this time this will be plus 0.35 into 200 into 0, and this from this we can get p is equal to, the value of p comes out to be 308.35 Newton. So we have to find the range of p for which this is in equilibrium. So p will be in this range, 168.35, and then p, then 308.35. So this is the final answer. We will write in this range. So this is how we can